Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you guys are doing good. In this, we're gonna see map of highest peak. Now, this problem is similar to another problem as well, which is 542 01 matrix. Let's see. It simply says that you are given a matrix is water of size m cross n. This is a matrix. Input matrix is water of size m cross n. What again? What this is the output matrix, but the input matrix is 0 0 1 1 0 0 0 0 0. 1 represents, as it's a is water matrix, so 1 represents that there is a water here, there is a water here. And for the place where it is 0, it represents it's a land cell. 1 represents it's a water cell. What you have to do is you have to assign some values, that is height, in a way that first condition is the height of each cell must be non-negative. I have to assign some heights, which means I have to make a corresponding output matrix. That specific output matrix should have values which are not negative, which means 0 or more. And also, if a cell is a water, its height must be 0. So obviously water cells height must be 0. That's it, that's a fixed thing. And next condition is any two adjacent cells must have an absolute difference of height at most 1, right? Which means that the adjacent cell should have a height difference of at most 1. If the height difference should be at most 1, then tell me what can be the value at this cell and this cell, because obviously for 0 these are the two adjacent cells only, right? So what should be the height? Obviously one possible height is 0, right? Then the adjacent difference is 0, which is at most 1, less than equal to 1. Next possible height can be 1. The difference is again a 1, which is less than equal to 1. Next possible height can be minus 1. No, it cannot be negative. It needs to be positive or 0. So we realize, okay, the possible values are 0 or 1, right? Here also the possible values are 0 or 1. Cool. Now, ultimately, your task is that find any such assignment of heights such that the maximum height in the matrix is maximized. So, obviously, I want that the maximum height in this entire matrix is maximized. So, how can we do it? Obviously, as we saw that we had two options, 0 or 1. Now, if I ask you, which option should I place here? Should I place a 0 or a 1? Then you might say, if I place a 0, then okay, obviously for his neighbors also I have to maintain that condition. Let's say if I place a 0 here also, then again let's say if I place a 0 here also, then obviously maximum height here is 0. It is not good. Rather, at every point where I can maximize, let's try to maximize it, which means its neighbors I'll try to keep it as, let's say, 1, right? His neighbors also I'll try to keep it as 1, right? And then okay, for his neighbors, like for 1 his neighbor, like, or let's say for 0 his neighbor is 1, so here also I will put a 1. Now what can I do? Here I can, okay, 1 has neighbors, so I can try to place a higher value, which is 2. And here also, I have a 1, then I'll try to place a value of 2. So I will be able to achieve this. Thus every cell is actually touching its potential maximum value, and thus ultimately when I try to make every cell touch its potential maximum value, thus I achieved maximum possible value of 2. And that is my answer, and that you can see is my corresponding output matrix. So you have to find an assignment of heights such that the maximum heights in the matrix is maximized. I have to return an integer matrix heights of size m cross n, where the height is the cell I comma j, and is this corresponding cell has the corresponding height. If there are multiple solutions, I can return any of them. So technically, I just want to return any matrix in which the maximum height in the matrix is maximized. So even if I return a matrix in which this cell is 0, that also is correct, because ultimately the maximum height in the matrix is 2, which is still maximum. But still I realize that it is much beneficial to always play safe, right? And thus always try to put up maximum value. Now this is what we realized, but how to solve it algorithmically? Let's see. So one thing we realized is that as soon as I just have to put up as max values as possible. Okay, that was the first condition. But the second condition was that the adjacent cells, which means for this cell 0, for this cell 0, in the very beginning, they are already placed, right? So no matter what, I will have to place a value here. I'll have to place a value here. I'll have to place a value here. Same way, because of this, I have to place a value here. I have to place a value here. So isn't it that for some points, I am trying to check their neighbors? So it is such kind of a traversal in which you start off from some points and you are exploring its neighbors first, and then from the neighbors you are going on next, which ultimately says that we will be using BFS traversal, because BFS says explore the neighbors first and visit the neighbors first. So because of BFS traversal, and again, because it's a BFS traversal, that's one thing. But is it a single source BFS traversal? No, I have multiple water nodes. So I will start off my BFS traversals from multiple nodes. Thus, it is a multi-source BFS traversal. Again, multi-source BFS traversal simply says that start the BFS traversals from multiple nodes. Here, in this case, is this one and this one. Now, if you want to practice more problems of multi-source BFS, or if you want to know more about it, just simply go and watch this one video of multi-source BFS traversal. Cool. Now coming on back, okay, we will do a simple multi-source BFS. How I will do it? Okay, obviously, I will put these 0 and 0 inside my queue. And when I say 0 and 0, which means corresponding row and columns. So if I just put it, the first one I will put up as 0 comma 2, this one. And then I will put up, again, this is inside my queue. And then I will put up my 1 comma 0. When I get this out, firstly, obviously, when I put up in the queue, I will assign their values as 0. That is one thing I have already assigned in the very beginning. Then when I got this out, I will get its neighbors which are not visited. How I will get to know which are not visited? Either I can maintain a separate visited array. Again, I was about to show you the tags, but these you can find in Telegram description, Telegram, Discord, or on the website codewitharyan.com. Now, coming on back, you will see that firstly visited this, we have to know that, okay, what all neighbors are visited or not. So by default, what we can do is we can put every value as -1. We can put every value as -1, -1, -1, because this is the height array which I have to find, right? So this will also help me to get what is visited, and this will also help me to get that what is the current value of height. Because the height value cannot be negative, that is the reason I can put a default value of -1. So I visited it, its neighbors are this one and this one, they're not visited. Simply get them a plus height, which is height, this height, existing height plus 1. So I got the existing height, okay. And then also put these neighbors inside my queue. So I will put up 0 comma 1, which is this cell, and also I will put up 1 comma 2, which is this cell, okay. Then get this neighbor, okay. I'll get this neighbor out, 1 comma 0, right? And then I'll visit its neighbors which are not yet visited with a value of this height plus 1, this height plus 1, and then this height plus 1. Okay, make sure to also put that inside my queue. So I will put up 0 comma 0, which is this cell, then 1 comma 1, and then 2 comma 0. Okay, then visit things again. So I will visit 0 comma minus 0 comma 1. So if I visit 0 comma 1, this is this cell. All the neighbors are visited. Okay, don't do anything. Visit 1 comma 2. Visit 1 comma 2, this cell. Okay, his one neighbor is not visited, just simply visited, which means I will put up a this height plus 1. So I'll put up 2 and then push that inside my queue, which is 2 comma 2. Then this is done. Next is 0 comma 0. All the neighbors are visited. Okay, simply remove it. 1 comma 1. Okay, one neighbor is not yet visited. Simply visit that neighbor with the value of 2, and thus get this out. Push the neighbor which is 2 comma 1, and simply keep on going forward, and now like nothing will visit it, so the queue will become empty. This is how a multi-source BFS actually works. Cool, let's see the code. It's exactly very same as what I showed you. It will start off by having a queue. Now considering I want to take a coordinate which is row comma column, although this is algorithmically right, but you know, if you're giving a L4 or a higher interview rounds, make sure to make a class of coordinates and then use it. It looks pretty much clean, but yeah, this also works. Then I have a height, which is the answer array, which I initialized with -1 as a value. right? And then I have the corresponding directions, which is the four directions which I want to traverse to. In the very beginning, for all the water cells, I will put their corresponding heights to the value of 0 and I'll push them in the queue. Then I will start simply my queue traversal. I'll get the corresponding front value of the queue, and then go to all of its neighbors, get the new row, new column for the neighbor, and then if check if that specific cell is a valid cell, and also that cell is not yet visited. The height -1 says it is not yet visited, because if it is visited, then the height will become some non, or I should say some positive height, 0 or positive height. 0 already done, so it will only become positive height. That is the reason if it is -1, it will indicate it is visited. And ultimately push that in the queue and keep on repeating the cycle until you are done with, or maybe, you empty the queue and ultimately return the corresponding height. What is the time? Time in itself here, you are going on to all the cells m and n once, thus the time will be O of m into n, which is a simple time as you go on to every cell exactly once. And considering you are using a queue, that is the reason in the queue, in worst case, I can also have m into n element at one point of time. That is the reason space is also O of m into n. Now, in space, you will never include the result. So I did not count this one into my space because it is obviously the answer which I have to return. So I will have to take that space. But extra space is the queue and the directions. Directions are pretty small, but the queue is the primary large one. Cool. I hope you guys got it. Bye bye. Take care. Make sure if you want to see the tags, if you want to see the different codes in different languages, please go and visit the website codewitharyan.com. Again, I'll link it in the description as soon as the article is ready. Bye bye.